There's an electrodynamics problem, and it looks like this. So it says there's a shell, spherical shell, and it's got a frozen in polarization value, a polarization vector of k over r in the r hat direction. Now I'm going to show you two ways that you can find the electric field everywhere. The first is to use Gauss's law. So, of course, Gauss's law says if we integrate the electric field over some surface, that's the total charge inside of that surface. Now, let's just take this region in the middle here. That's the part that's complicated. What charge would be inside of there? There's actually two charges you need to consider. There's a surface charge density due to that polarization. We can calculate the surface charge density. It's just P, the polarization dot n hat, which is pointing inward in that case. And then we have the charge density, which deals with the divergence of the polarization. So you can calculate those two things. You could also calculate the surface charge density on the inside, the outside, and then the total charge density. You do have to use spherical coordinates for the divergence because it's in spherical coordinates. And once you do that, you can set up your integrals. You can calculate the total charge. You can do the electric field, the flux, the surface area of the sphere, and you can get the electric field in that region as this, negative k over r squared. Now, the other way to do this is to use the displacement field. The displacement field only deals with free charges. And so in this case, there's no free charges anywhere. So the flux of the displacement field is zero everywhere. However, we define the displacement field as epsilon naught times the electric field plus the polarization vector. So wherever there's a polarization vector, we're going to have an electric field, which would be in here. Since that's our polarization vector, we get the same thing. This should be 1 over, oh, that's the density. I said r squared. E is 1 over k, negative k, epsilon naught over r, and you get the exact same thing using the displacement field. Two ways to solve the same problem. And you can see using the displacement field makes this a lot easier because it says just find the effect of the free charges and then worry about the effects from the polarization of the dielectric material later.